to the Radical Job Shop Show, where leaders of some of America's most vital and under-the-radar small businesses go deep and get gritty about what it takes to build a bold, profitable, and impactful shop. I'm your host, Emily Joanne Wilkins, founder of Marketing Metal, the anti-agency that helps machine shops, fabricators, and custom equipment builders craft a radical brand that leaves behind a legacy. This is the Radical Job Shop Show.
We are here at Spectrum Machine and Design in Windsor Locks, Connecticut. And I'm about to get a shop tour from the owner, Gary. Follow me. Oh, hi.
Hey, welcome.
Hello.
Welcome to Spectrum Machine and Design.
Thank you so much. Hi. You're such a good girl. What's your name?
Her name is Reagan.
Thanks so much for having me.
Yeah. Welcome to our shop.
All right. I'm excited.
Come on in. We'll show you around.
Okay. No, you guys stay here and protect the entryway, huh?
Security level 1.
Security.
Well, come on in.
Thank you. Okay.
So we're an aerospace shop primarily, focused on aerospace and defense, specifically aircraft engine parts. We can do anything from blades, vanes, blisks, cases, combustors.
And they're part of the engine, so they're extremely important.
They're critical, and then if you ratchet it up another level, rotating components we do as well, and that's a whole nother level of criticality. These are things that actually are rotating inside the engine, so they're rather important.
Rather important.
Yeah, it's a big deal. One thing we're doing right now on every machine with our ProShop Rollout is we're putting in a 24-inch touchscreen. This will be the operator interface for timekeeping, processing jobs. It'll be the DNC interface for programs in and out of the machine. Basically, all the interaction that the individual would do is going to be done through this screen. So operation sheets will be all digital, because then you're working with one truth and there's no out-of-date copies floating around the shop floor.
Yes, single source of truth is very important.
Correct.
How did that process go with your team?
Good. It's just getting finalized now. I don't think we've finished every machine yet, but we have the majority of them done, and we're running ProShop right now.
Yeah.
But
were they excited about it?
Oh, yeah.
Wary?
No, it's been
long time coming.
Yeah, really has been a major improvement in shop floor control. Gives us clear visibility into what our costs are and how to manage our work better. This is one of our sinker EDMs. We're approved for EDM for NADCAP and OEM approval as well, okay, for both wire and sinker. We bought this for a part we were doing, development part in 2021, and to find a machine with a big enough tank was a little bit of a challenge, and we didn't want to be held hostage with our one-off part when somebody was doing production work and whatever. So we ponied up the cash to buy a new machine.
Just for one project?
Yes, but we've used it since then because we knew that they would come in useful. So we've EDM'd several other components since then. This is a recent acquisition, a piece of machinery. It's replaces an optical comparator.
Yeah.
So, but you don't need a Mylar for it.
Okay.
If you're familiar with optical comparators, you have to generate a Mylar on a plotter, and then you use that for your comparison. Right. This uses a 2D image, a CAD file. So you're comparing it against a theoretical perfect image, and it's optical. It's using a camera to look at the part rather than a shadow.
Yeah.
And it's really got a lot of cool features.
So this is more accurate than a CMM?
On checking radii, things like that, thread profiles. There's certain things CMMs don't do well.
Gotcha.
but this really was a major improvement in that area.
Cool.
This is our CMM room, so inspection.
Hello.
Hello. Everybody smile.
Hi.
How are you?
Good, how are you?
Good.
What are we checking today?
I'm inspecting these shroud segments, shroud retainer segments.
They're made out of Waspaloy. There's a little bit going on inside the groove. It's not just a simple groove. It's got a dog bone profile down inside. But we actually machine those out of plate. So we're wire EDMing a segment, then turning the segments, then milling the segments. And it's quite a bit to it because typically they would be made out of a sleeve, a round sleeve to start with.
And then bent, right? But you don't want to...
No, they would be turned as a circle and then segmented. We're actually making them backwards because the material is not available.
Oh, okay.
So plate was available, and that's what we worked out with our customer to be able to make them that way.
Very cool.
We have an order for 2,000 of these, 2,000 of a similar part number.
Okay. Nice.
Yeah.
How long does it take you to make 2,000 of those?
I've been going a couple weeks. All right?
Couple weeks?
Yeah. Yeah.
So how many different machines do those touch then?
Maybe 6 combined between EDM, turning, milling, CMM.
Yeah.
Yeah, part marking.
Oh, yeah. And you program the whole inspection process, right? And then looks like you're doing 3 at a time?
Custom fixture here. Yeah, this part we're only doing the one station right now. We have another program that runs 12 pieces.
Okay.
Six.
Cool.
Yep.
You have to check every one?
Yep, every piece.
Yeah. We generally do 100% inspection on everything, even if there's 20,000 pieces. And you can see there's a little dog bone profile with undercuts. It's pretty specific.
So you worked with your customer's engineers to develop the process to actually make this part?
Correct. Yeah, and Jessica is working on some clamps over here. These are parts that we make out of solid stock. They were a casting. There's like 60,000 pieces to be made. Yeah, so they're really high volume, but there's, I don't know, maybe 50 different part numbers. There's quite a few.
And you have to inspect every one.
Yep. Everyone fully. So these are some of the parts we make. This is a hog-out. Starts as a solid block of 17.4 stainless. It's a pump housing for an aircraft engine. So there's bearings that go in these diameters, but the diameters are tight tolerance and they have to have a 16 finish on them. We're getting about a 5. Hold plus or minus 5/10 on the large diameters and plus or minus 2.5 on the small ones. So they're fairly high precision. And we make about 20 a week of that part.
What else we got?
This is another part. This is a part for an aerospace engine.
Aluminum, I'm guessing?
No,
No?
Inconel.
Oh. It seemed like you picked it up like so easy, like it was just nothing.
No, it started as
Strong man.
Yeah, not really. Started as a heavy wreck forging, so it was I don't know, maybe a 400-pound chunk of material when it started. But it's in process. We have a bunch of pockets to mill into it and so forth.
Okay.
But it'll look like a fancy part when we get done.
I mean, it already looks like a fancy part.
And just other components. Everything is either land turbines or flying parts. So.
Land turbines?
Yeah, like for marine or power gen. These are actually what they call a ground pounder. They're a bracket for a GE engine.
Okay.
That generates electricity. So.
Gotcha. Okay, so you do a little bit with energy then too.
Yeah. Yep.
And you said marine, like submarine?
No, like battleships.
Okay.
We have a part that we're making up in this big machine that's a gearbox bracket for a gas turbine that goes in a battleship.
Okay. Cool.
And we can go take a look at that if you want.
Yeah.
So this is a 5-axis mill turn. It'll swing up to 90-inch diameter. You can do pretty good sized parts in here. He's finishing the bores in that part, which are plus minus 2.5 tenths on diameter, which is pretty tight. So we design and build all our own work holding. We started as a tool shop, but now we don't do tooling for anybody because we need all our capacity for our own production. But our shop is relatively young. Our average shop age is 33. So you have us 50, 60 somethings and then much younger folks.
Yeah.
So,
That's
but
good.
we have a really good crew of people. Really,
How many people you have?
37.
37.
Yeah.
That's an EDM bag?
That's a wire EDM, yeah. That was actually our first brand new CNC machine we ever bought because we were a tool shop.
Yeah.
Having a wire EDM was like awesome.
Right.
It works all weekend by itself.
Amazing.
Yeah. So here's a little clearer view anyway.
Wow.
So we've got several of these to make over the next few months,
Okay.
but they
How long does it take to make one part?
about 8 working days.
And this is all one part that's on here, or is there two?
Yes. No, that's all one part. Yeah. Yep. Yeah, if you saw a casting out by itself, it would be more clear, but
Okay.
it is kind of weird the way it's mounted on the fixture.
Cool.
But then we do assembly on it after NDT. We do a full CMM inspection, do the assembly, and then pack and ship. So here's an example of a swing gauge. You were wondering what they were when we calibrate them.
Oh, yeah.
So this would be used for measuring a diameter in a VTL or other lathe.
Okay. What's a VTL?
This is a VTL, or vertical turning lathe.
Oh, I've never heard it called that before.
Yeah,
I don't know if I've ever seen a vertical lathe.
really? Well, I mean, that's the Akuma is essentially a VTL with 5-axis milling.
Oh,
So this is a VTL. This is a straight VTL. This will turn 36-inch diameter. It's not too much different than if you took a regular horizontal lathe and just stood it on its end.
yeah.
That's really all it is. In a VTL, gravity works in your favor because your part is not trying to fall out of the machine. The part is setting on a table essentially.
Okay.
So you can find situations where both horizontal lathe and a vertical lathe have their unique advantages, but sometimes doing large ring,
Heavier.
things like that, heavier objects,
Yeah.
a VTL is more useful. This machine here is a scaled down version of the 2000 that we just looked at. This will swing.
Scaled down?
Yeah.
Looks the same.
It's very similar, but it'll only swing 60 inches. But the head and the travels, the XYZ travels, are actually the same. This is actually the part we're running in this machine now.
Okay.
So this is a part where we're taking Inconel 718 casting. We call it a Franken-Part because it's taking a casting from one engine program and modifying it to work for another engine program that the casting is no longer available. So the casting that for the end use program had these ears on it. So what we do is we machine these out of solid wrought material and then we electron beam weld them to the casting.
Crazy.
So that solved a major problem for our customer.
Because they already had a bunch of these made.
These are existing because there's an existing engine program that these are used for. So, but they're very similar to the one that the casting was no longer available for. So by taking the casting that is available and modifying it with adding the ears, it solved the problem. So
Cool.
yeah. Initially there was a thought of TIG welding the ears on, but this area here on the casting is only 80 thousandths thick, and you would have gotten a lot of distortion. So electron beam was a better solution in this area. But it takes more effort to vet it and say that it's acceptable. It's just a more complicated process, but you end up with much better results.
Okay. So it takes longer to prove it out.
Yes, exactly. These are some other parts, Inconel parts that are sisters to that piece we looked at earlier.
Okay.
These are in process. Again, Inconel hog-outs. The segments, this is the material those come from. So there you're seeing what we start with pretty much. We start with a heat-treated Waspaloy plate and then cut the segments out of that.
And you're using the wire EDM for that, right?
Correct. Because it gives us a very precise blank to start with. So this is kind of a cell here between these two lathes. These parts that start out as solid bar right here wind up as those that you see on the bench. So these are input shafts for a jet engine, for a gearbox. We make 15 of those a week from solid bar.
Okay.
So this runs pretty much nonstop, 2 shifts. So we developed special tooling to be able to cut the interior grooves. The grooves are a mirror they're basically an image of the exterior.
Okay.
So these are the segments that you looked at in the CMM room. So we make them, because of the plate thickness, we make them as a 2-unit part, and then we split them in 2.
Oh, okay.
There might be sharp edges, so.
Yeah. Cool. And this isn't complete, is it?
It's complete as far as the groove and the exterior surfaces.
Okay.
The
And
only
then you
thing-
gotta cut
Then
them.
we split them in 2, and then we machine that split face.
Okay.
And then we machine the ends too. So there's still a little bit of work left to it. Hey, buddy. Good.
Hello.
This is Emily. Emily,
Hi.
this is Pete.
Nice to meet you, Pete.
So we're running, these are bore scope plugs for an aircraft engine, machined out of Inconel. So these start as a solid bar.
Okay.
Then they have some pretty deep interior cavities. And these actually do get sink or EDM. There's a square that gets EDM'd, as well as a spherical radius down at the very bottom.
Oh. Okay.
So it'd be very difficult to do with any other method.
Yeah. Is this that machine?
Yep, yep. So you can go up inside the machine if you want and look. So this machine here, this is a five-axis mill. It's in the kind of the middle size range. Is there a part in there?
Yeah.
Okay.
It looks like R2-D2's head.
That's a vision system for a military drone. It houses the vision system. This machine here and this horizontal next to us is tied into our pallet tech. So any one of these 12 pallets can go into this machine or into this machine all automatically with no operator involvement.
What?
Yes. This is a pallet pool. So instead of having 2 pallets on a machine, you've got 12 pallets. So you could go and...
I've never seen a pallet changer that goes between machines.
Well, this is modular. We can add, basically in 6 pallet increments, we can add pallets as we add machines. So we can go up to 36 pallets.
That is amazing.
But you could go in here for an operation and then come to this machine for 2 or 3 operations, then go back to this machine for an operation with no operator involvement. The pallet system controls everything.
Wow.
So basically the white trolley travels up and down the track, and we'll go get whatever pallet that it's told to and either bring it to this load station or to a machine or both. Basically does whatever it's told.
Yep. And it's manual, like you manually load
You
it.
manually load it through that booth. Looks like a bit of a phone booth there.
Yeah, yeah.
Or you can load through the machine door as well if you want, without using the pallet system. So it's flexible however you want to do it. As you notice, we have mostly Mazak machines here. Their Northeast Technology Center is right next door.
Oh, that's convenient.
Yeah. So it's been a good relationship. They use us for a showroom
Okay.
because we have a lot of variety of machines.
Yeah.
And if we need support for something, they can just walk across the parking lot.
Nice.
If they don't respond, we throw down a nail strip out in front and stop them that way.
Nice.
So this is a part that we run on a regular basis. This is a jet engine split case. It's about a 20-hour cycle where we do 5 parts a week on this particular part number.
You make 5 of these a week?
Correct.
Wow.
Yeah. So this is an interesting little part. This was a part that was a casting and went to a hog-out. So this is all machined out of 310 stainless solid bar. We machine the part, do all the inspection on it, and then we assemble these little shank nuts into it, swage them, then the part is complete. We program in NX, which I don't know if you're familiar with that. 2 of the OEMs that we deal with design in, so our software is compatible with their files. We do our tool design in Solid Edge, which is NX's little brother, I'll say.
Yep.
So that software is directly compatible as well. And then we also use Vericut for verification of programs prior to going to the shop floor.
Looks like you have a full bench of programmers.
Yeah, we have currently about 7 people that do programming. Yeah, that's actually my son. That's him there. He's our 3D printer operator. Kind of embraced that, and he really likes dealing with it. But it's actually a very useful thing. You know, we use that for a lot of inspection fixtures, marking fixtures, prove out things, just to give you a touchy-feely model.
Yeah. That tail's got some power behind it, huh?
Yeah, it's like getting hit with a garden hose.
Oh, yeah. Yes. Oh, you're very sweet, huh? Yeah. Oh.